Hey everyone, so for all the people who have been commenting they want a map 3D tutorial in English, this is a trial introduction to map 3D. If you guys like it, comment so that we can continue this series in English learning map 3D, Meyer Sound MAPP 3D, which is a very effective tool for your personal practice about alignment and also to get done with your shows or integration projects where you are using Meyer Sound. Cheers. So this is how the map 3D looks like, and let's quickly check what are the screens and what are the parts that you need to know so that you can start designing your first project. So left side, this is our inventory list where you get all the speakers, all the geometrical figures, the galaxies, all the speakers, and all the microphones that you'll be adding to your project. This is your main middle window where you'll be designing your project, and right side you get different kinds of structures and shapes and layers so that you can start designing and making everything in separate layers. So quickly, let's check the project setting, and in this video I will show you exactly what I do and only the necessary features that you need to start designing and getting accustomed with the map 3D. So this is where you get all the settings and you can change between feet, meters, so imperial or metric. Environment, so use air attenuation. This is like with the air absorption features, which you can turn it off right now during your designing stage and turn it on and change the values just to see in the real environment if you know where you are going for your next show. So then comes the appearance. I will always keep my show grid and show annotations on, and this is where these are the default value and you can always change the values depending on your project. And then comes the SPL. This one we will check out a bit after some time. So they normally have 110 max SPL value, but depending on your project, when you start predicting it, you will start seeing over here also, and this correlates, so we will start working with that. But yes, one thing what I will do is like resolution should be 3 dB per color, so that we know the changes, and changes in color will reflect directly on how things are going in our project. Okay, so let's go to the appearance and quickly make a venue. So this is, let's just go to manual. Let's just design a small 100. So this is plus minus 100. So total 200 meter. Okay, so again, let's just quickly, because we want to check, so we can just quickly design a smaller venue. You can see. So now I'll make different layers. So one layer might be the plane, the surfaces that I want for the venue. The next layer can be stage. The next layer can be the speaker tops. The next layer can be subs, front fill, and then the microphones that you'll place so that you get to see the frequency response on the ground. Okay, so these are the bare minimum thing that we'll start to design here. So let's quickly put a stage here, and we double click and select the stage layer, and we can also change the color of different things. So let us keep the speaker tops purple, subs as blue, front fill orange, and the microphones, you can see this is all black. That's why let me keep the microphone as white so that I can place the microphone and I can see it directly over here. So let's make a quick stage. You can click the rectangle and you can click anywhere and it will give you a default value of 5 meter by 10 meter, which then you can also change. So wherever you click, that will be dropped here, and as soon as you drop something here like this rectangle, you can see in the geometric figure you have dropped a rectangle, and now you can turn it on as a prediction plan or deactivate the prediction plan. So let me quickly delete it, and let me again put it somewhere close to the center. Let's make it 10 by 20 meter. So that's like the stage, and 0 and 0. So now you see the center point is here when I have made it X and Y 0 and Z also 0, because I want it to shift a bit back, and I will be making my design in the red line, the X axis. You can press space and you can move it like this. Okay, and with shift, you can, holding the shift, you can move the entire plane, and you can holding the space bar, you can rotate the plane. Okay, so now let me quickly select it, and this is x-axis. So if this is 10 meters, so you know this is 5 and minus 5. So let me just shift it to minus 5, and you see this is right here. And now let us go to layer, select plane, and go to a rectangle and make a rectangle over here. Let us quickly make it like a 50 meter by maybe 30 meter plane. So 50, half of 50 is 25. So y-axis will be 0 so that it will be exactly in center, and half of this is 25, so it shifts here. You can see. Now let us turn on the prediction plane. Now these are my prediction plane. So in the plane setting, so let us quickly rename. So this is rectangle, so this will be my audience, and this is my stage. So ideally I know the stage will be at a reasonable height, so we can just change the height here. Maybe it's 0.7 meter, and you can see it's at a height right now. And also in the rectangle, in the audience, I know the audience will not be lying on the ground, right? They will be sitting or standing. So either I take either I can make the entire plane like a 1.5 meter, or the same thing, you can go here, object setting, and make an offset of 1.5 meter. Now you can see the rectangle is down wherever the prediction plane is up by 1.5 meter offset. Okay, so now we can quickly check out the venue, and this is the venue. The prediction plane is a bit up for the audience. And now what we can do is, like, quickly we can place a speaker and see a prediction. So today's video is going to be quite short. This is mainly to show you the practical things that you need in a MAPP3D to start your design. And you can comment on what are the next things that you want so that we can check it out. So insert a loudspeaker, and you can see there are different types of loudspeaker that you can place here. So I'll show you quickly. So either you can go for a flown loudspeaker, ground stack loudspeaker, gradient flown subwoofer array, point source array, endpoint systems like a horizontal system, horizontal array, or an individual speaker. Today, let's go with an individual speaker. Let's go with an Ultra X40. Let's give it a height of 3 meter. I want it in the 0 axis of Y and 0 axis of X. So that makes it at exactly the point where at the edge of the stage. Okay, and we can close it, and now you can see this is my speaker. See, this is my X80. Now I want to see where my X80 is pointing, so you can go to view, center line, and you can see it is at straight, pointing straight, right? I want to tilt it a bit down, so you can quickly go to express setting, select your speaker, and you can see there are different parameters. So if now I want to adjust the speaker, I can also do it with the mouse scroll, so that with the mouse wheel that I can adjust things, and I can also make it at different angles, and I can also tilt it down as I want. So let's just tilt it down like this and quickly see its prediction. Okay, so let us select the speaker, and you can see this is at 4 kilohertz, 1 octave pink noise. Okay, so let's predict, and you can see right now that you get a prediction over here, right? And now you see you get some default value over here. The maximum SPL is 91, minimum is 51. So I can right click, apply max SPL to the project, and you see some pretty good response over here. So this is the very initial start how you can start predicting. So it will be great if you can comment and tell me what is that you're looking for to learn in MAPP3D, so that I can accordingly plan the chapters and keep uploading in this playlist about learning MAPP3D in English, so that it can help you all. Do not forget to like and subscribe. It helps me immensely when you like and subscribe the channel. This gives me immense boost to think about the next topics, all about pro audio and integration related audio topics, that I can share my experiences and the tools that you need to learn to be proficient in this career field of audio engineering. Cheers.